Hello, welcome to video number 55. We've made it to the end of the unit. This is the last video of our unit on square roots. Okay, in this video we're going to talk about converting repeating decimals to fractions. So a rational number is a number that can be written as a fraction. And if a decimal terminates, we should be able to write it as a fraction. And if it has a repeating pattern, we should be able to write it as a fraction as well. And that's what we're going to learn how to do here. So once you get kind of the trick, then you can do all of these. So right here we have 0.512 repeating. So this would be equal to 0.51212, etc. That's what the dots mean. So that pattern 1 2 1 2 1 2 keeps going. Okay, so the secret is to multiply this by a power of 10 to move the decimal place to where the pattern begins. So I'm going to let x equal the number we're trying to find. So x equals 0.512. I want to find a fraction for x. So 10x would be equal to 5.1212, etc. repeating. So if I multiply our original number by 10, the decimal place would be right there before the 1. Now, the second step is to multiply it by a power of 10 that would move the decimal to the end of the first pattern. Okay, so we want to move the decimal place 3 places. So we have to multiply by 1,000. So 1,000x, that move it 3 places, and we have 512.1212 repeating. Okay, now this is what we do. We're going to subtract these expressions. I'm going to do the bigger one minus the smaller one. So 1,000x minus 10x is 990x. Now, something interesting happens here. When I subtract these numbers, since the decimal parts are the same, excuse me, since the decimal parts are the same, they're going to cancel. And really, what I have left is 512 minus 5, which is 507. Okay. So now I just divide by 990. I have 990x equals 507. If I divide both sides by 990, I get x equals 507 divided by 990. All right, there it is. I'm not too worried if I can reduce this or not. Our job is to write x as a fraction, and we did it. And if you did this on your calculator and checked, you did 507 divided by 990, you should see 0.512121212 repeating. So we can check to make sure we're right. Alright, so actually I'm just going to be doing that trick over and over again. On this one, the pattern starts here. So we want to move the decimal place 2 spots. Okay, so our original number is x, so 100x would be 79.42 repeating. So 4242 repeating. Then I want to move it all the way to the end of the first pattern. So I have to move it 4 places. So I need to multiply by 10 to the 4th, which is 10,000. So 10,000x would be 7,942.4242. And the reason why this trick works is because now notice that the decimal portions are the same, and we subtract them, they cancel. So 10,000 minus 100 is 9,900. X equals, now the decimal part I don't have to worry about, it's going to cancel. 7,942 minus 79 ends up being 7,863. Okay, and then when we divide, we get 7,863 over 9,900. Wow, we did it. So we're proving decimal's repeating. It should be a rational number. We're proving it's rational. We're writing it as a fraction. Okay, let's try this one. We'll let this be x. Now, we see that already the decimal place is at the beginning of the pattern. The pattern starts right away. So we're going to use just x itself. We don't have to multiply by anything the first time. So it's 0.784784 repeating. And now I want to move it to the end. So we need to multiply by 1,000. 1000x is going to be 784.784 repeating. Again, the decimal portions go on forever. They're the same. When we subtract, they cancel. Okay, so let's do it. 1000x minus x is 999x. 784 minus 0 is 784. So we divide, we get 784 over 999. If you haven't done any of these, you just got to kind of do a couple and get the hang of it. Alright, this one, the pattern begins right after the decimal, so we'll use x itself. 2.5959 repeating. And then we want to move it 2 places. So 100x would be 259.5959, etc. So again, we got the decimals the same. That's the reason why we're doing this. Then subtract. We get 99x equals. Those are gone, and I just have 259 minus 2, which is 257. So we'll finish it off. 257 over 99. Okay. It's got 2 more quick examples. But really these are kind of the same thing here. Nothing new. Just got to decide what to multiply by. Here the pattern starts right there before the 3. So we want to move the decimal place 1. So if this is x, 10x would be 471.3. Then we want to move it after that 3, just one more spot. So 100x would be 4713.3. Okay, and these 3's are repeating. It kind of goes on forever. Alright? Bigger one minus the smaller one. That'd be 90x. And 4,713 minus 471. I got this here. I think is 4,242. Okay, then we divide. Kind of a cool trick, but this is all there is to it. And so, ideally, any repeating decimal pattern we could do this with. Okay, this one is 4. The pattern's 4 long. It goes 1144, 1144 forever. So, since the pattern starts right away after the decimal, we can use the original number. So 0.1144, then be 1144, etc. And then we want to move it all the way to the end of the first pattern. It starts repeating there. So if we want to move it 4 spaces, we got to multiply by 10 to the 4th, which would be 10,000. So that'll move it all the way over to there, and then we have the same repeating decimal. Subtract, and we have 9,999x equals. Okay, and all of this mess, the part that matters is 1,144 minus 0. So it's just 1,144. And then when we divide, we get 1,144 divided by 9,999. I don't know why I like this. It's kind of cool. So if this is totally new to you, you're going to have to do a couple. So maybe try a couple of these examples on your own and see if you get the same thing. And we got something for you to practice. You do a couple of these, you'll have it down. So here are 4 for you to do. Remember, go back and check out the examples. This first one, you can use the original number, and then you want to use 100x. So just to make sure you're off to a good start, on this first one, let x equal 0.7878 repeating, and then 100x would equal 78.7878 repeating. And then subtract them and solve for x. Alright, you got a bunch of examples there. I think you'll be okay. Take care.